Hi everyone, today we are talking about similarity and transformations. As a reminder, you do not need to write down everything that we'll cover, but be sure to jot down important information and at least one example of each type of problem that we'll cover. Also remember that you can pause the video to jot down important notes, rewind to view information again, and fast forward if you think you got it. Be careful, make sure you don't fast forward too much that you miss out on something important. So as a review, similarity and congruency. Congruency is when you have very similar looking figures. They're like almost the same. So that's why we have the equal sign with the squiggle on top of it. And the similar figures are the same shape, but everything else is pretty much different. They can be different sizes, they can be in different locations, different orientations. They're just similar. Rigid transformations like translations, reflections, and rotations create congruent images, but only dilations will create two similar images. Important to remember that congruency, all corresponding angles and sides are equal in measure, but for similar shapes, only corresponding angles are equal. The corresponding sides are proportional to each other, meaning you have to multiply by a number or divide to get to the other. There's a multiplication or division relationship there. Be sure you have this in your notes if you don't already. So for the similarity and transformations exercise, you're now given the 4 different transformations: translate, rotate, reflect, and dilate to work with when you're trying to map one shape onto the other. However, you need to do that in order to prove whether it is similar or congruent. Remember, similar means that they don't have to be the same size, but they have to be similar. And then for congruent, it means they have to exactly map onto each other. So go ahead and pause the video and try this one out first. All right, I'm going to first try rotate because I'm going to rotate around point E. Oops, oh, this is the one I need to move. So I'm on the wrong one there. So ABC needs to map onto DEF. I've just put it on the wrong thing. I'm going to turn it, and then it looks like I just need to slide it. Remember, you can come up with your own steps, as long as you can try to map it on there. Okay, so these are not congruent, but that's not what the question is asking us. They're asking if they're similar. So remember, similar means that the angles are all the same. The angles look like they're all the same. Let me see if I can show you a better way here with my pen maybe. Oh, I can't draw in there. Worth a try. All right, so it looks like our angles are the same. Obviously, angle F and angle, looks like this was angle A. They're right on top of each other. If I were to move angle D to match up with angle B, they're right on top of each other as well. Angle E and angle C match up. So I can kind of shift them around so I can just check that the angles are the same. Remember, for similar figures, angles are the same. But everything else is proportional, meaning I would have to multiply to get there. It looks like I would multiply by a number to get to the next larger length. Same here, and same for DE. So this looks like it is, yes, similar. They're following the same shape. The lines match up when you move them. The lines match up. If they didn't match up, then we would have a problem. Let's try another one. Go ahead and pause this video and try it on your own first. We want to figure out if they are similar. You're mapping this blue one onto the pink one. All right, this looks like it might need a rotation as well. And it might look something like that. Let's translate it up maybe. Maybe we had to rotate it a little bit more. maybe. Maybe a little bit more. It's not really matching up there. So that kind of gives you a hint that maybe it's not similar. Let's do some translating. Ah, there we go. See, these angles are not the same. And these angles are not the same, so I couldn't really match it up. So here, this is a sign. Well, these are the same, but all the angles have to match up and be the same. You're not following that same line. This one is not the same as well. And these are not the same. So this would be a no for similar. They're not similar. They look similar, but in terms of the math, it doesn't add up. Okay. All right, here is a third example, and I'm going to actually show you how to use the dilate. I didn't really use it on the other two. Here's a great example of why checking with the dilate tool will actually help you. Because here, what I would probably first do is reflect over to the other side so it has the same orientation, and then I would translate it over, and I would say, hey, look, all these look the same. This checks out. But if I use the dilate, let's put this point over here and drag it out, I would see, hey, look, it doesn't actually match up. So the angles matched up, but it was hard for me to look at what it would basically be the result after I dilated without actually dilating it. So when I actually use the dilate tool, I see, it doesn't add up. It's a little short or a little long on some of them. So that's what we mean by proportional sides. That's a little harder to check out with just your eyeball. So you might want to use that dilate. Okay? All right. So that's all the tips I can give you. Let me know if you have any questions for me as you work on these, and I'll see you in class.